Okay, so today we are going to do 2.2. And we're going to start with assessing normality part. Assessing normality. In other words, how do we know if we truly have a normal distribution? Okay, that's what they're saying here. Okay? This is what we mean by assessing a normality. Okay, so let's look at page 131. Look at 131. There's a dot plot at the bottom where it says the number of siblings. So they did a survey to find out how many siblings each person has. And they got the following thing. So the question is this a normal distribution or not? How do I know if this is a normal distribution or not? You flip the page. Okay, this is a dot plot and summary for calories per serving in 77 different brands of breakfast cereal. Okay, and then that, so which one looks more like a normal distribution here? Is it the first one we looked at or the second one we looked at? What do you think? I think the first one looks a little more skewed to the right, whereas the second one looks more like a normal distribution, right? Okay, it's kind of hard to tell because we have 77, so it's not as much the end, the population is not that big, right? Okay, so the question again is this: how am I going to find out? So if you look at figure on the paragraph there, it says figure 2.20 shows a dot plot numerical summary. So actually what they did is they tried, now that they know, since they know the mean and the standard deviation, all right, the mean was, what was the mean? Mean was, the standard deviation, okay, the mean was 106.883. 883, so this was the mean, and you had a standard deviation of 19.49, 19.484. And what they did was they're trying to see if the 68, 95, 99.7 rule holds. In other words, if I go here and I go from here plus or minus 1 sigma, and I count within that range how many, what percent of the data I have is what they're doing, right? If I do that, I get what? So from 1 plus or minus 1 sigma, I get 81.8%. Okay. So when I do this, I'm going to apply this to the serial data, and I do this plus or minus sigma, I get 81%, 81.8%. If I do mu plus or minus 2 sigma, I get what percent? I get 92.2, and plus or minus 3 sigma, I get 100%. Okay, so it's just close, because in 1 sigma I'm supposed to get 68, I get 81.8. 2 sigma I'm supposed to get 95, I got 92.2. 3 sigma I'm supposed to get 99.7, I got 100. So this is pretty off. This is not close, right? I'm supposed to get 68%, and I had 82%. So this is a bit too much. And this guy here is a little less, but yeah, that was okay. 100%, 99.7, they're about the same, so that's okay. This one's okay, this one's a little off, this one is way off. So I'm gonna say that this serial thing does not follow a normal distribution, okay? So that's that. So let's see if we can do that same thing, doing example on the example. Are IQ scores normally distributed? Okay, many people believe that the distribution of IQ scores follows a normal distribution. Is that really the case? To find out, researchers obtained IQ scores of 60 randomly selected 5th grade students from one school, and here's the data. Okay, so again, they're going to do a histogram, and they're going to find out if the 68, 95, 99.7 rule works. So if I gave you this question on the test, how would you find the mu and the sigma here? How would I be able to do that? Anybody? You would just populate it to L1, right? You would put everything in L1 and do a 1-var stats test, right? You do a 1-var stats test, and that'll give you the mu and the sigma, and then you can work from there. As a matter of fact, if you look at the solution, okay, underneath the histogram, it gives you the mean, the standard deviation, and then the 5-number summary, right? The minimum, Q1, the median, Q3, and the max, right? Okay. And if you do that, it looks like on this one, you're going to get 68.3 for 1 sigma. You get 95% for 2 sigma and 100% for the 3 sigma. So yes, this one looks like it's approximately normal distribution. Okay. Right. Another way to find out whether or not it is a normal distribution is by finding or doing the normal probability plot. So there's a thing called the normal probability plot. Okay, you would do this. If you look at the green thing, it says, the green box, it says, a normal probability plot is a scatter plot of the ordered pair, okay, the data value and the expected z-score for each of the individuals in a quantitative data set. That is, the x-coordinate of each point is the actual data value. The y-coordinate is the expected z-score corresponding to the percentile of that data that is in the data value in a standard normal distribution. Okay. Underneath there is an exam tip that says that the normal probability plots are not included in the AP Stats topic outline. However, these graphs are very useful for assessing normality. You may use them on the AP Stats exam if you wish. Just be sure you know what you're looking for, okay? So yeah, so what they're saying is that it's not something they ask for, but if you are asked to assess whether a data is normal or not, you can use this, okay? You can use the normal probability plot, because if you use this, it's something that the calculator spits out for you. You don't have to sit there and draw a histogram and do the 68, 95, 99.7 rule. Okay, you can just go ahead and do the normal probability plot. So what you're looking for, if you flip the page, okay, those are on the left-hand side of A, B, and C, you have the dot plot. And on the right-hand side, you have what is called the normal probability plot, okay? So if you look on the top of page 135, it says that if the points on a normal probability plot lie close to a straight line, then the data is approximately normally distributed. Okay, so you're looking for a straight line there. If you have a straight line on the normal probability plot, you have an approximately normal distribution. Because the question is, well, how do I get that? If you flip the page, on page 136, it tells you in the technology corner how to do a normal probability plot using your calculator. So if you go there, it says you go to Stat, Edit, and then you put in the L1 values, all right? And then you go to Stat Plot. When you go to Stat Plot, there is a normal probability option there. Okay, everybody see that? Okay, this comes up often enough that you should know this, okay, in the AP Stats test, okay? So if you go back, let's flip back and let's see if we can do the example there, okay? So the problem, how normal are survival times? Researchers recorded the survival times in days of 72 guinea pigs after they were injected with infectious bacteria in a medical experiment. A normal probability plot of the data is shown. Use the graph to determine if the distribution of survival times to approx times is, okay, the plot of data is what? Use the graph to determine if the distribution of the survival times is approximately normal. So they did a normal probability plot, and what does this tell you? What are you looking for in a normal probability plot?
For it to be in a straight line.
You're looking for a straight line. Is that a straight line?
No.
Obviously not, right? So you could say that the survival times are not approximately normal. Okay. Okay. And that's it. Okay. So this is how you, so that when you're talking about assessing normality, okay, the first one we talked about was do a dot plot or a histogram and do the, see if it falls into the 68, 95, 99.7 rule, the plus or minus 1, 2, or 3 sigma. See if that works, right? And the second thing we could do is a normal probability plot, which is a lot easier because all you have to do is just put the data in the calculator and go ahead and plot it out, okay? All right, now let's go back to the start of 2.2 and see if we can go over the learning objectives and see if we know all the learning objectives. Let's go to page 109, the learning targets. The first learning target is use a density curve to model distributions of a quantitative data. Okay, that was like modeling the train time and all that good stuff, okay, where the area underneath has to be 1, that kind of stuff. Second one, identify the relative locations of the mean and median of a distribution from a density curve. Okay, remember we talked about if you have a normally or a approximately roughly symmetrical, something like this, where the mean and the median would be on the same place versus if I am skewed to the left or skewed to the right, how the mean gets pulled away because the mean is not resistance to outliers, right? Whereas the median is, okay? Next one, use a 68, 95, 99.7 rule to estimate the proportion of values in a specified interval, okay? We've done that. If I were to use technology, what would I use to do these things? Which function do I use? Cat. What's the function I would use in my calculator? To find the areas between one point to another? Huh?
Is it the L1 plot?
What?
Can you hear me?
I can hear you. Yeah. What did you say? What was it? What?
You hit stat and then you go to the L1 and you put in all the numbers.
No, not one of them. You would do the norm CDF, right? You would do the norm CDF. The norm CDF. Okay. Again. Now, when you do the norm CDF, what do you have to do on the test? If you have a,
you put in the upper and lower.
Yeah, you have to go ahead and label.
And then you have to label it.
You actually have to label it. So if I go from 0 to, last time we were doing 90 with 80, I think it was 80 and 5, you have to go and write lower limit, upper limit, right? And then you have to, this is the mean, and this side is the standard deviation. You have to actually label it like this, okay? If you just give me this, you're not gonna get full credit. Okay. All right, that's that. And this one is find the proportion of values at a specified notion using table A or technology. So table A, if you remember correctly, had the z-scores, and you had to calculate all the z-scores to find out what the percentages were, okay? And then the next one is find the value that corresponds to a given percentile in notation. So that would be the inverse norm, CDF. You'd have to do is the inverse norm. Okay. Last one, determine whether a distribution of data is approximately normal from graphical and numerical evidence. So you would go, again, you would do do the dot plot and histogram and do the plus or minus 1, 2, and 3 sigma test to find out if it is the 68, 95, 99.7, or you can just put it in your calculator and do the normal probability plot. Okay. Are there any questions of what we talked about today?